In this video, I will show you how to use slope, length, and midpoint to prove different things about triangles, quadrilaterals, and diagonals. So, for example, I'm supposed to show whether or not triangle ABC is isosceles, scalene, or equilateral. Well, isosceles means that there are two congruent sides. Scalene means there are no congruent sides, and equilateral means there are three congruent sides. So, obviously, we need to find the lengths of the sides, because congruent sides means equal length. So, let me start by making my introduction statement that says, I will use length. Okay, so let's find the length of each of the sides. So, for example, I need to find the length of side AB. So the easiest way to find the length of a segment that is drawn on a graph is to use the Pythagorean Theorem. The horizontal distance here is, let's see, I see 4 and 5, so that must be 9. And the vertical distance is 2. Okay, so that means that using the Pythagorean Theorem, it's going to wind up being the square root of 9 squared plus 2 squared. That's 81 plus 4, so that's 85. So this is going to be the square root of 85. Okay, now let's keep going. I guess I'll change colors just so you can follow it more easily. Let's find the length of segment BC, and that's going to be the square root of, and again we're going to look at the horizontal change and the vertical change. Alright, so we can do the Pythagorean Theorem. So this is 6, right, okay, and this is, that's 4, alright, I think that's 7. Okay, 6 and 7. So that's going to be the square root of 6 squared plus 7 squared. Okay, I'm going to go ahead and use my calculator a little bit. So 6 squared plus 7 squared. That's 85 again. All right, very interesting. So far I have two congruent sides. So this is definitely not going to be scalene. All right, it's down to either isosceles or equilateral. Let's find the third length, and then we'll know. So what about AC? Okay, so one more time, we'll do the Pythagorean Theorem. We'll draw a right triangle so that AC is the hypotenuse. The horizontal change is 3. The vertical change is 9. Okay, so that's going to be the square root of 3 squared plus 9 squared. Okay, so 3 squared plus 9 squared. That's 90. All right, so I have two congruent sides, so that means this is going to be isosceles. Okay, and notice the pattern that I'm doing. Anytime I'm trying to prove or verify, I always make an introductory statement, and then I show my calculations, and then I make a conclusion, all right, that answers the initial question. All right, but in this case, they want me to circle isosceles, so there you go. For problem number 12, which of the following quadrilaterals always have two pairs of parallel sides? Circle all that apply. Okay, which have two pairs of parallel sides? Well, let's start with this. Everything on the left side of the screen is a parallelogram. And as you can see right here, Well, I started to highlight it in yellow, but it's right there in the box, already in yellow. The definition of a parallelogram is opposite sides parallel. That means we'll have two pairs of parallel sides. So, all of these shapes over here are parallelograms, so they will all have opposite sides parallel. Okay, so which of the quadrilaterals always have two pairs of parallel sides? Well, let's start with parallelogram and then rhombus. Okay, because parallelogram and rhombus. If they had said rectangle or square, I would have circled those two. But kite, trapezoid, isosceles trapezoid, these are not parallelograms. These do not have opposite sides parallel. Number 13. All right, I feel like switching colors first. Got to switch it up sometimes. Which of the following quadrilaterals always have perpendicular diagonals? Okay, now, I've really memorized that chart. So as soon as I see perpendicular diagonals, two things pop into my head. Rhombus and kite. Those are the two shapes that have perpendicular diagonals. Now, if you look on this chart, you're going to find that same information. Here I see diagonals perpendicular. That's for rhombus. And here I see diagonals perpendicular. That's for kite. But again, that's why you need to have all of this information memorized so you can pull that off the top of your head like I just did. All right, you just have to have this stuff memorized. Okay, moving on to number 14. Okay, for number 14, this is one of those proofs. And we need to have the introduction, the body, where we show the calculations, and a conclusion. All right, we're supposed to show that quadrilateral EFGH fits the definition of a rectangle. So right away, first you have to know what the definition of a rectangle is. Hopefully you know that a rectangle is a quadrilateral with 4 right angles. Okay, that's the definition. So our introduction is that I will find slopes, okay, to show 4 right angles. All right, I will find slopes to show 4 right angles. That's my introductory statement. Okay, now, the way I will show 4 right angles, by the way, is if we have right angles, that means we're talking about perpendicular lines. So if I need to show that these sides are perpendicular, because that means 90 degrees. That means right angle. So how do I know if segments are perpendicular? Their slopes should be opposite and reciprocal. So that's why I'm finding these slopes. So let's go in order. So let's start with EF. All right, in fact, let me write slope. We're going to find slope EF. Okay, let's do rise over run. So if I go, it's down 3 over 2. So that's the slope. It's negative 3 over 2. All right, that's slope EF. Okay, now let's find slope FG. Slope FG. Okay, I might erase as I go to make room. Okay, FG. Let's do rise over run. So this would be rise and run. So what did I just do? I went up 4 and over 6. All right, so that's 4 over 6, which reduces down to 2 over 3. Okay, notice these are opposite and reciprocal. Reciprocal because 3 over 2 and then 2 over 3. That's reciprocal. Opposite because the first one's negative and the second one's positive. So that means these are perpendicular. All right, just like we thought. Let's move on to slope GH. Okay, slope GH. So let's do rise over run. That's down 3, right 2. So that's negative 3 over 2. All right, now of course these two again are opposite and reciprocal. So that means FG and GH are perpendicular. And finally, let's do the last remaining slope. Let's do slope HE. Okay, HE. So let's talk rise and run. So this is up 4 and over 6. So that's 4 over 6, which reduces down to 2 over 3. And again, these are opposite and reciprocal, so they are perpendicular. Even these, if I wrapped around and I compared slope HE to slope EF, these are also opposite and reciprocal, which means that these are also perpendicular. So that's it for the body. I have my clear calculations shown. So now it's time for the conclusion. So let me go ahead and write it down first. So there's my conclusion. Since consecutive slopes are opposite and reciprocal, the sides are perpendicular. So EFGH is a rectangle. Okay, let me just zoom out a little bit so you can see it all at once. All right, this is how these problems should look. Okay, with an introduction that tells whether or not you're going to use slope, length, or midpoint, and the calculations in your main body, and then a conclusion to wrap it all up. Let's do that again. Okay, so now we know that EFGH is a rectangle, so its diagonals must be what? So again, it's all about this chart. Okay, let me flip away from it for a second. You should know off the top of your head what the special property is for a rectangle. Okay, specifically, what about those diagonals? Are they congruent? Are they perpendicular? Are they parallel? Or what? Well, diagonals cross over each other, so it doesn't make sense that they could be parallel. That doesn't make any sense. So the question is, are they congruent or are they perpendicular? Well, for a rectangle, the diagonals are congruent because of symmetry. Okay, if this diagonal and that diagonal, those should be the same length. They are not perpendicular. Look at this angle. That's not 90 degrees. All right, so they're not perpendicular, but they are congruent. Okay, so that's the key. So this is, and if you've memorized this, then it's right there. Rectangle, the definition, 4 right angles, the property, diagonals are congruent. Boom, it's right there. Anyway, so how do I show that things are congruent? I find lengths. All right, I will find lengths to show diagonals congruent. Okay, now we will do the calculations in the body. So I just said we were going to find lengths, but we're only talking about the diagonal. So don't go finding the lengths of everything. The diagonals are, for example, HF. I think I'll use my drawing tool so I can make this a little tidier. That's a diagonal, and this is a diagonal. Okay, those are the two diagonals. So I need to find the length of HF and I need to find the length of GE. By the way, if I just write HF with no segment symbol over it, it means length. Same with GE. So the way we can find the length of these diagonals is we can just, well, okay, we could either use the distance formula because they gave us these points down here. So I could use the distance formula. Maybe I'll just do that. So HF, okay, we're talking about these 2 points right here. So if I did the distance formula, all right, to find the length, remember that it's x minus x, so it would be like 5 minus -3 squared, and then it's y minus y, so that's going to be 2 minus 1 squared, okay? So I could really use my calculator to help me out. So this is going to be 5 minus -3 squared plus 2 minus 1 squared. All right, and now I could have done that in my head, but I'm showing you that you can use a calculator if you need it. And that gives me 65. So that means I have the square root of 65. Now let's find the length of GE. So since now I'm talking about GE, okay, now I'm talking about these guys. So again, if I want to do the distance formula, I will do x minus x. So 3 minus -1 squared. And then y minus y. So that'll be 5 minus -2 squared. Okay, so here I go again. 3 minus -1. All right, or I could have just put 3 plus 1. Or I could just put 4. All right, so you can work out as much of this as you want to. Well, 4 squared is 16, so I could just put 16. So 5 minus -2 and squared. Or this is the same as 5 plus 2, which is 7. 7 squared is 49. So I could have just put 16 plus 49 if I wanted to work out a bunch of stuff in my head. Anyway, I get 65. So just like before, I got radical 65. So that's it for my clear calculations. All right, I just did the diagonals. They're asking about diagonals, so I'm not going to go finding the lengths of all the sides. All right, that would not make any sense. So now the conclusion, I'm just going to write, since the diagonals are the same length, the diagonals are congruent. And there you go. Since the diagonals have the same length, they are congruent. All right, and that's a full little proof of this special property of a rectangle. Just one more time, I cannot emphasize this enough. It's important that you have the definitions and properties of these 7 shapes memorized. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.